All right, so we get to our final section in chapter 9, which talks about the laws governing how compounds will form. So the laws of definite and multiple proportions. We have two laws that describe the proportion in which elements combine to form compounds: the law of definite proportions and the law of multiple proportions. The law of definite proportions says that a chemical formula will tell you by the means of the subscripts the ratio of atoms of each element in the compound. And ratios of atoms can also be expressed as ratios of their masses. For example, if we have magnesium sulfide, it's composed of one magnesium and one sulfide ion. So similar to that, if we have 100 grams of magnesium sulfide and break it down into its elements, you would obtain 43.13 grams of magnesium, because that's the atomic mass of magnesium, and 56.87 grams of sulfide. The ratio is 43.13 to 56/76 because that is the mass of those two elements. And they're in a 1-to-1 ratio. So we can simplify that down to be a ratio of 0.758 to 1. Magnesium sulfide obeys the law of definite proportions, which states that in the samples of any chemical compound, the masses of elements are always in the same proportion. Sorry, I had a typical in my throat. The law of definite proportions is consistent with Dalton's atomic theory. So Dalton postulated that atoms will combine in simple whole number ratios. And if the ratio of atoms of each element in a compound is fixed, then the ratio of their masses is also fixed. So in the early 1800s, Dalton and the others studied pairs of compounds that contain the same elements but have different physical and chemical properties. And using the results from these studies, Dalton stated the law of multiple proportions, which states that whenever the same two elements form more than one compound, the different masses of each element are in the ratio of the small whole numbers. So for example, copper 1 chloride is green and copper 2 chloride is blue. Both contain the same elements, but in a different ratio. And that's what gives them their different properties, physical properties of green and blue. Another example, water, H2O, and hydrogen peroxide, H2O2, are formed by the bonding of hydrogen and oxygen, but these two compounds have different chemical properties and formulas. Naming guidelines from chemical formulas. So we follow the rule for naming acids when hydrogen is the first element in the formula. And if there are two nonmetals, then you are going to use prefixes to indicate the number of atoms. If the compound contains a metal and a nonmetal, you use the ionic naming rules. So let's go through an example. Is there a hydrogen? So then we reviews given in table 9.5 of the textbook. If Q is not a hydrogen, are there more than two elements? If there's not, is Q a metal? If it's not, use the prefixes in the name. If it is yes, you asked if it's in group A. So you'll name the ion, or you'll name the ion with a Roman numeral with a cation. If there's are there less than two elements, you ask if the group in group A, and you name the ions, and if not, use the Roman numeral with the cation. So kind of a complex chart for chemical names and formulas, but hopefully it will help with a couple of these. Writing chemical formulas, an IDE ending indicates the compound is made of two elements. And an ite or ate ending means a polyatomic ion that includes oxygen in the formula. And prefixes in a name generally indicate that the compound is molecular. A Roman numeral after the name of cations shows the ionic charge of the cation. So here is another chart to help you practice the chemical names and formulas. You take the name of the compound. Does it contain a prefix? Yes, then you use prefixes to write the formula. No, you use an ionic compound. You identify the symbols. You look at table 9.1 to obtain the charges if you're working with group A elements. You use Roman numerals given the charges for the cations. And if it's a polyatomic ion, you use table 9.3 in your textbook to obtain the charges. And then you'll balance the charges by using the crisscross method where they go to the opposite element. All right, so please work through those practice problems in 9.5, and I will give you more in Moodle as well. Take care, everyone, and God bless your studies.